Welcome to the January Novice meeting. And again, my name is Chris Morisette, Novice Chair for the Houston Astronomical Society. Tonight's presentation is one of our quarterly presentations on introduction to the sky, how to navigate, and to get an idea of what objects are out there for us to find with our telescopes. This one being the winter sky. So for tonight, what we're going to do is the following. Wintertime can be cold in Houston, so we're going to talk a little bit about that, how to prepare for the elements. We'll have a quick refresher on navigating the night sky, cover some reference material that may be a benefit if you're brand new to the club. We'll then talk about Orion as a signpost, and we'll also point out the different areas of the night sky that we're going to be interested in during the winter time. And then we'll go through a selected a list of winter sky objects. I must confess to you that the winter sky is one of my favorite skies, and Orion in particular is probably my favorite constellation. So a lot of great targets out there for us to go out and observe and enjoy. And then at the end of the presentation, I want to give you some information on an upcoming novice lab that we'll be trying to pull together here in the next month or so in order for us to go out and practice finding these objects that we're talking about tonight in the presentation. So without further ado, let's move on to the main topic. So winter is here for about a week or a few weeks. Kind of a joke, but Houston can get cold. I know here recently it's been a little chilly in the morning when I've gotten up. Went out Friday night to do some astrophotography in the driveway and do some visual observing, and it was pretty chilly. However, you can beat the cold, and it's worth paying attention to your wardrobe and updating your gloves, your hat, jackets, etc., in order to be comfortable when you're out there underneath the stars in the winter. And as a rule of thumb, what you want to try to do is dress for a temperature that's about 20 degrees colder than what you're going to have to experience. I think part of the logic behind that is that when you are out viewing and looking through telescopes and observing the night sky, you're not moving around a whole heck of a lot. And as a result, you tend to get colder faster, and the extra layers will help keep you warmer during that period of time. Here's what I would recommend as far as just kind of the minimum in order to be ready to go for a night out in January, February, even into March. Certainly a beanie or a stocking cap. I don't have much upstairs here in the hair department, so I lose a lot of heat out that way, and a beanie or a stocking cap keeps the heat in. Certainly a winter coat. I have an old winter coat I think it's back from my high school days in Washington State. It's a big old thick down jacket, kind of like George Costanza wore in an episode of Seinfeld. So it may look funny, but it keeps me warm. Also, having some thermal or moisture-proof pants as a layer to go over a pair of jeans is good. It can get moist out there. And again, any wetness will tend to get you colder faster. Gloves, thermal socks, the typical kind you'd wear on a hiking trip or snow skiing. If you've got hand and foot warmers and little packs that you can buy that you can bust open to stick in your pocket and keep your hands warm, that's always a good idea. Boots are good. I've got a pair of safety boots that are cowboy boots, and it's nice to have that protection up above the ankle, and not only to protect the ankle but to keep the feet warm. And then long underwear, bottom and top if you've got them, always a good addition. You'll also want to take a blanket if you can, because again, if you're sitting out underneath the stars, having a blanket there will just give you one added layer. So here's a my kit here that I use, and the again, I was going out Friday night. I was sitting in the den, nice and comfortable. Telescope was already set up. I was just waiting for it to get dark. And I'm saying to myself, do I really want to go out there? And it's like, well, I have set everything up. I've got to go. So I was kind of dreading the cold. I went into the bedroom, put on the outfit that you see here on the left, and got out there, and I was feeling good. And that lasted pretty much almost the entire time I was out there. My feet tend to get cold uh, early, and so that tends to remind me that it is cold out there. But having this kit on outside, I felt comfortable and felt, which allowed me to focus on doing the things that I needed to do. This item that you see on the right is a really cool item I found at REI. It's a blanket, kind of a down blanket, but it's also has a hood up here, and it sort of fits like a poncho. So you can put it on around you. There's a couple of buttons in front that you can snap shut. I think there's even some pockets on the side. And again, it's a really nice feature, a really nice way to take a blanket out there in the during your nighttime viewing. I also made some investment in electric socks to try to. Again, my feet are my personally my feet tend to get cold first. I've had kind of mixed results with these. The first hour or so, they're great, but the batteries go out quickly. So I either need to get another pair or some more batteries so I can have a fresh set charged. But again, another thing to think about as you get ready for the cold weather yourself. Okay, so that's a little bit about prepping for the evening. Now we'll get into navigating the night sky. We'll take a little bit of a refresher. I tend to cover these during our quarterly reviews, quarterly sky tours. So no harm in hitting these again. So just some basic star chart terms. And this is, for people that have been in the club for any length of time, I'm sure this is old hat. But if you're new to astronomy, these are really important concepts. So if you can imagine our own Earth here in the center of the picture, and we're surrounded by what I would call a celestial globe or a celestial sphere. And on this sphere are all the stars and the planets and the sun and the moon and everything that's out that we can look at during the night sky. This is kind of our frame of reference or our model that we use in order to find our way around. And so for the planets and our sun, you'll find those objects on this dotted line here called the ecliptic. It's not the equator. It's not a pole. It's just a line that you see here that the planets and the sun ride on. The moon, for the most part, does, although there's a bit of an offset in the way the moon orbits the Earth. But that's for our solar system objects. For stars, for galaxies, for nebula, things like that, there's another system that we use called right ascension and declination. And what this essentially is, it's just a coordinate system like latitude and longitude here on Earth that we can use in order to find an object on the celestial sphere. So right ascension is analogous to, think of it in terms of a latitude or a longitude measurement, excuse me, and then declination being analogous to latitude. And each object has these coordinates, and by using those coordinates, you can find that object on a reference map or on a planetarium piece of software, etc. So those are really key, interesting things to remember here about finding our way around the night sky. You'll also notice a celestial North Pole and a celestial South Pole. That's really just the imaginary line, and it actually is the same as the Earth's axis of rotation. And that, again, just kind of helps you orient yourself on this model. One thing that is really important to recognize is that your location on Earth will determine, how that celestial sphere appears to you and moves throughout the night. So if you're at the North Pole, like this person here on the left, what you're going to find is zenith, or is the Polaris, the North Star, being right above your head, and you'll see the Big Dipper and Orion's belt, at least a piece of Orion's belt, circling around you as the night progresses. So they really the Big Dipper will really never go below the horizon. It'll always be above you. As you move farther south, that changes. And what you want to remember is Polaris in the night sky. You need to, in order to find Polaris, you need to face north, but you need to look up above the horizon here in Houston about 30 degrees. If I was in San Francisco, which I think is like at 38 degrees or 40 degrees, I think it's 38 degrees, I'd look up above the horizon at 38 degrees. So the angle, or the altitude that Polaris is above the horizon is the same as the latitude that you were at when you were looking at when you were observing. So another key thing to remember. So here in Houston, we're looking at 30 degrees above the horizon to the north, and we'll see Polaris, and we'll find stars like Orion, the Big Dipper. They will rotate around us. The Big Dipper will a piece of that actually does stay above the sky, but not all of it does. Orion will rise in the southeast and set in the west. So that's important to recognize, as well as some of the other constellations that we'll talk about tonight. But that's a key thing to remember. Now, this is another perspective. When we're here on Earth and we're looking and we're using those first two slides to kind of, get our sense of where things are in the sky, inevitably we ask ourselves, well, where are we in relation to everything else? And this pictorial gives you an idea. This is not to scale, obviously, but here's our solar system with our sun, and here's the ecliptic, which is that dotted line that I referenced on 2 slides ago. And then here we are, planet Earth right here. And what we're doing is showing the orbit of Earth around the sun. And you'll notice at this point here, 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 and here, those are actually points in time that were, changed, where we're changing seasons. So we just went into winter here on December 21st. And this is roughly where we are at in our journey around the sun in relation to where we are looking at out into the cosmos. So, you see here the Milky Way and the central dustling of the Milky Way. You'll see here we're looking at night, we're looking out away towards the edge or the outer boundary of the Milky Way. We can still see the galactic disk of the Milky Way, but it's a lot fainter because than what we would see during the summertime, which is over here, because we're not looking back in at the core like we are, say, in June and July. So this is hopefully will give you an idea of where we are at with relation to everything else. And when we talk about the spring sky here in April, we'll be up at this point, and you'll begin to see why we refer to this as galaxy season in the springtime. But more to come on that. Again, I don't want to dwell on this too much, but it kind of inverts everything. And the other 2 slides, it was kind of like Earth centric. This is more galaxy or galactic Milky Way centric. A couple of we'll start out and talk a little bit about references. One reference that I highly recommend is a monthly map that a website called skymaps.com puts out. Here you see the January 2024 map. This is free, easy to download in a PDF and then print out. On the left-hand side here gives you all kinds of things that are going to be happening during the course of the month. But the key thing over here is this circle, which is really our night sky. So as I'm out looking at the stars and I'm facing south, I want to have my sky maps in this orientation here with south on the bottom. And then what I'll be able to see are the various constellations that are up in the sky. So here is Orion, which we're going to talk a lot about tonight, Taurus the Bull. And again, here's the ecliptic where the planets reside, and then you'll see Jupiter here. So it's a short, sweet, and free reference for you to go download and use, and a great way to get started. If I'm looking north, what I would do is I would turn the map 180 degrees around so that north was on the bottom. And then here's what I would see up in the night sky. So a couple of things of interest are Cassiopeia and Perseus, two constellations that we're going to talk about later in the program here. And again, this is going to give you an idea of where these reside. Now, these pictures, we'll go back to the previous slide. If you look up in the right-hand corner here, it gives you in early January, this is kind of what you'd see at 8 o'clock at night. Later in the month, because as we progress around the sun, our night sky changes throughout the course of the months and the seasons. You'll see the same sky that you're looking at here, only at about 7 o'clock. So this is what you'll see at 8 o'clock early in January, 7 o'clock later in the month. Again, if you're brand new to astronomy, just a couple of references here I'd like to point out. Curious George, if you've got kids, you may remember the book Curious George by an author called H.A. Ray. He's a children's author, but he did a couple of really great books on astronomy. One called Find the Constellations is really good because what he does is he's able to connect the stars for various constellations to make them more resemble the legend or mythic figure that the constellations are supposed to be. So, for example, Orion, the hunter, he has connected the dots, the stars, if you will, to really make that more vivid than you might find in some other references. Again, it's a children's author, but don't let that dissuade you. If you're an old person like me, it is still very useful, and it's a quick way to get up to speed on recognizing the constellations. As you advance in your astronomy knowledge, you'll see some other guides here. The Pocket Sky Atlas. I had Turn Right at Orion. These are more in-depth reference material, reference books that you can use to get a deeper understanding of the night sky, the various asterisms, objects, etc. So this is another great set of references. My all-time favorite, though, is this. It's like one of these big books in the size of a gas station map, and it's called the Deep Map 600. And what you get on the front page up here is kind of a flattened view of the celestial sphere, and there are quite a number of stars, major stars, as well as objects, galaxies, clusters, you name it, that are identified on this chart. And then when you turn it over, what you've got is a very kind of lightweight database of information for each of the objects shown on the other side of the map. So things like their declination, their right ascension, their apparent brightness, what the object is. Is it an emission nebula? Is it a globular cluster? So on and so forth. Gives you a really neat, handy reference here, as well as some explanations on the various items that you may not have realized. So again, I love it because it's packed with information. and it just fits in the palm of your hand and doesn't take up a lot of space. Okay, enough about the Deep Map 600. Let's get on to the main topic for tonight. So let's talk about Orion. And we're going to start out here. So this is the celestial sphere in a flat version of the celestial sphere. And the green box that you see on the screen is the area of interest for us for this winter. And you'll notice smack dab in the middle is Orion. And so what we're going to do is we're going to talk about Orion and how you use it to navigate to other parts of the sky. But we're also going to use Orion. We're also going to talk about Orion because Orion is just chock filled with some really interesting and very accessible objects. So Orion's going to be a main topic of discussion. We'll be going over to Taurus, the bull. We'll be moving up to Auriga, which is a constellation directly above Orion's head. We'll be going over to Canis Major and talking about some objects there. And we'll also be visiting Gemini over here over Orion's left shoulder. And when we turn north, we'll look at Cassiopeia and Perseus, which I mentioned here earlier. But this in a nutshell is our area of interest for our winter sky viewing. You'll notice these other objects or other things here, these other yellow bordered items, the Big Dipper, Arcturus, Spica, the Summer Triangle, and the Teapot. Those are going to be signposts that we'll utilize in the spring and the summer and in the fall. But right now, for our purposes, we'll talk about Orion. So here is Orion. What you'll see tonight. I didn't look at the forecast. I wasn't sure if the sky was going to be clear. I think tomorrow night's supposed to be pretty clear. So if you don't catch it tonight, you can catch it tomorrow. But at 8 o'clock, 9 o'clock rather, after the presentation tonight, go out on the driveway and look to the southeast and see if you can see the three bright stars that make up Orion's belt, which is right here. And so that's the reason we focus in on Orion is because number one, it's easy to find. And then number two, as we're going to demonstrate here, it can point you to a lot of different places in the night sky. Here's another picture of Orion. It shows more of the object, the arm out here, and I think this is his shield, and this probably is a club or a sword up here. Down here is his belt, and then of course where the Great Orion Nebula is, that's where his sheath for his sword resides. Here are his shoulders, and then down here are his feet or his kneecaps, one of the two. Okay, so here's how we use Orion to get around to the night sky. So if we want to go to Taurus, what we want to do is we want to find a big red star called Aldebaran. And Aldebaran is kind of the main big star in Taurus. And the way we can find that is by traveling along the belt of Orion and following that out until we run into the bright red star Aldebaran. Once we run into Aldebaran, we're in Taurus, and then we can start looking for objects around in Taurus. Okay. To get to Gemini, and the two bright stars that we'll want to focus in on are Pollux and Castor. You want to go from Rigel, which is kind of his right foot, as we're looking at Orion, going up here through his left shoulder and following this arrow out. And if you do that, you get to Gemini. To get to Procyon, which is in Canis Minor, you follow, and we'll talk a little bit about Canis, not Canis Minor, but Monoceros, which is in between Canis Minor and Orion. We'll follow the shoulders out here, and we'll get to Procyon. And then to get down to Canis Major, we want to go to Sirius. And you probably don't need much of a direction from Orion to get you to Sirius because it's the brightest star in the sky. But by going down the opposite way along the belt, you can get to Sirius And here again, once you've got to Sirius, then you're into Canis Major. So let's go dig a little bit deeper down into the winter sky. So I guess before I move on, just let me recap here. Here's our main signpost. By connecting the dots or moving through the various stars that are part of Orion, we can get to different parts of the sky. And so it's really important as you go out and you look at Orion to be able to recognize or identify these 7 stars that you see here. And luckily for us, Orion is easy to find. The stars are really bright and you can't miss it. And if you do miss it, well, we're going to have a novice lab to help you not miss it. All right, winter sky objects. So let's move on. So Orion itself has a lot of really neat stuff. We're going to focus in on this region. This first picture that I've got from one of our club members is really a nice wide field of view that shows a couple of really interesting objects in Orion. And here's what we've got. So this is a wide field image. And what we're looking at here is M42, which is the Great Orion Nebula. And then up here, you can see the Horsehead Nebula right here. And it is tucked right in around this star called Alnitak. And Alnitak is the lower left-hand star of the belt. So this is where we're at. And so this next, when you look at the picture, it's kind of rotated over on its side. But the cool thing about Orion here, we're going to talk a little bit more about Orion. And here's a really nice sketch of Orion. Here is what you can expect to see through a small telescope or even binoculars. And this is really the key cool thing about this nebula. It is a nebula. It's a star-forming region, yet you can see it naked eye. And even with a small telescope or binoculars, you can really see a lot of details. You can make out the glow, which is really the clouds of the nebula. Here's what you'd see, or what the Hubble telescope brought back to us from Earth, or from out in outer space. So much more detail and color here. And then here's what our own Don Selly was able to do here. This is a nice image of the Orion Nebula. So let's talk a little bit about the Orion Nebula, because it is a very interesting object. It's about 1,400 light years from Earth. It's a fairly wide region. It's about 35 light years in size, and it's the closest region of massive star formation to Earth. So what's happening here is you've got really a nursery or an incubator for new stars. There's about 700 stars in various stages of formation. And there are even somewhere in the neighborhood of about 150 protoplanetary disks that have been discovered. So in addition to creating these stars, we're also getting what we think are initial indications of planetary formation. So very cool, very interesting, very lovely object, and again, very accessible. Out at the dark site with the naked eye, you can see a lot, and with binoculars and a telescope, it's really cool. So that is definitely one to put on the old observation list. So here's what we're going to do now. I mentioned from that wide field of view, we could find the Horsehead Nebula. It's another famous nebula that's in the constellation of Orion. And as I mentioned earlier, it's up near this star called Alnitak, which is the lower left-hand star of Orion's belt. And if you just excuse me a second, I'm going to get a drink of water. Much better. Here's a nice picture of the Orion of Alnitak, of the region around Alnitak. Here's Alnitak right here, and then here's the Horsehead Nebula. And you might notice something a little bit different about this. It almost looks like a shadow. And the Horsehead Nebula is actually a dark or absorption nebula. So there is gas and dust there, but it's of such a nature that the starlight behind it is blocked. And so that's what you get there, is that kind of that profile or silhouette, if you will. There are some other cool objects that are in this small view of the cosmos. So over here we have the Flame Nebula, and the gas here is being ionized, no doubt, from Alnitak and some of the other stars that are close by. You can see dark dust lanes here, which again are indications of a dark nebula. And then there's some reflection nebulas here and here, and I think this one is also reflection nebula. Again, they're not emitting, they're not being ionized by starlight, but rather they're reflecting starlight, and they tend to kind of look bluish, just kind of as a general rule. There's also a 5-star system up here, a group of 5 stars up in this part of the picture as well. So, just in this small field of view, you can see a lot of different things. I've seen I think the Flame Nebula is definitely a candidate for you to see with a telescope out at the dark site. Whether we can get out there and see the Horsehead Nebula, I'm not sure, but we can sure give it a try. Anyway, very cool. All right, so moving along here, what we're going to do now is go out and look at the Rosette Nebula. It's another emission nebula, and that's in a constellation called Monoceros, which sits between Orion and Canis Minor, which and the major star being Procyon. So about a third. I'm trying to remember. So remember, our signpost says we follow the shoulders out to Procyon, and if we do that, we'll come out here. I think roughly halfway between Betelgeuse and Procyon, you're going to find the part of Monoceros where you'll find the Rosette Nebula. And the Rosette Nebula is what you see pictured here. Again, another emission nebula. The Rosette Nebula is about 5,500 light years away from Earth, whereas the Horsehead and Orion were in the neighborhood of about 1,500 light years. So this is a little bit farther out. You'll also notice that there is a kind of a donut hole, so to speak, here in the middle of this thing. There's actually a group of really highly energized stars that are radiating, giving off a lot of radiation, and that radiation is creating stellar winds that are actually pushing the material out of the center of this object, which kind of gives it its rose moniker or name. Again, you can see some dark dust lanes in here that are very pronounced, that are absorbing starlight, and very cool looking object, and relatively easy to find. So that's the Rosette Nebula, and really that the whole nebula is about 128 light years across, but this hollowed out region is almost 30 light years. So those stars are doing a lot of moving around, a lot of pushing of material around. Okay, so now we're going to go and follow Orion's belt out to Aldebaran and get to Taurus the Bull. And so here is kind of the or the shape, if you will, of the constellation, and that's how they got the image or the view of a bull. And here's where we get to when we get out to Taurus. So here's Aldebaran, and here you can see the horns of the bull going up this away and up that away. And the first thing we'll talk about here is the Hyades, which is a cluster that is an open star cluster that's in and around Aldebaran. Aldebaran is not part of that cluster because it's a foreground star. The stars in the cluster are about 150 light years out, whereas Aldebaran's only 65 light years away from us. So that is, but we can use it as a marker. If we can see Aldebaran and then we can see the cluster, we'll be able to see the cluster next by. We can just kind of use it as a guidepost as well. This cluster has about 300 to 400 stars. There are 5 main members that are all red giants, and that's an important thing to remember too. as you go out and prepare for your viewing, if you're going to be going after a star cluster, it's a good idea to know if there's any different colored stars, any distinctly red stars or blue stars that are in that cluster. Knowing in this case that we've got 5 red giants, that will allow us to look at this cluster and confirm that yes, indeed, that is the Hyades. That's what we're looking at. So just another tip in order to help you understand if you're on the right spot. Here are some asterisms that are in Taurus. There's one called Ali's Braid, and I'm not sure if that's related to or part of. It is part of Pleiades. So we'll talk about Pleiades here in a bit, but there's an asterism within Pleiades called Ali's Braid. There's one over here called Davis's Dog. I'll be honest with you, I've never gone out and looked at that before, but certainly can give it a shot during our upcoming lab. And then down here we've got the Delta Wing, and my favorite is the Triple Double. So let's look at the Triple Double. So the Triple Double is actually 3 sets of double stars that are in close proximity to each other. Now, if you look at this, you might say to yourself, well, which pairs are we looking at? And that's what we're looking at. So these are really cool. I'm typically not a big open cluster aficionado or fan, but this one I really get a kick out of because the pattern is so crisp and clear that it's really cool to go find it and pick it out. When I was out Friday night, I was imaging the California Nebula, and as things were clicking away on the computer, I got out the binoculars and looked right up at Aldebaran, and boom, very easy to find, even in light polluted suburbs like I live up in here in Kingwood. So really a neat open cluster. Here is another view of Aldebaran and Taurus. And in this particular case, we're going to look over the right shoulder of Taurus, and we're going to go look for an open star cluster called Pleiades. And Pleiades is, again, it's an open cluster, but this one's a knockout, and it's really cool for a number of different reasons. Just a few facts about Pleiades. It is an open cluster that's about 430 light years away from us, so it's relatively close, about 15 light years in size. The cluster contains hundreds of stars, and this bluish color that you're seeing here is actually gas dust in the cosmos that's reflecting starlight. And this picture right here almost looks like a Van Gogh painting, reminiscent of Starry Night and the swirls, etc. But you may be saying to yourself, "Well, that can't be real." Is that really what is up there, or is it something else? Well, when you go out, and when I go out anyway, and I look at Pleiades, you can see Pleiades naked eye, and it's pretty apparent that you can see it. And to me, what it reminds me of is kind of a group of incandescent grapes. And naked eye, it's difficult for me to make out the colors, but when you're looking through a binocular telescope, I'm getting up in age, so my eyesight's not what it used to be. But you can definitely see a tint, a different coloration than what you'd see with the surrounding stars. So it's really cool, really a neat object to see, and it's again a very accessible object for you to see in the night sky. You can actually make it out naked eye. So I love it. The Crab Nebula is another really interesting object in Taurus. This one resides right above the head of Orion. He's on the left-hand horn of Taurus. This is actually a supernova remnant. It is about 6,500 light years away, relatively small, so you need a pretty big telescope in order to see it. But what you're seeing here is the end result of a relatively large star that has run out of fuel and died and catastrophically imploded. And that's what we're looking at here. There's a pulsar that's in the middle of that mess of what looks like electrical, almost lightning bolts that is spinning at about 30 revolutions a second and emitting all kinds of energy from gamma rays all the way down to radio waves. So pretty interesting object. We'll turn our attention to Auriga. Now, there's no signpost per se to get you up there, but if you just follow up the top of the head of Orion, you're going to get up to Auriga. And the one bright star to kind of look for when you're up there is called Capella. And so that's a simple way to kind of get your bearings. But once we get to Auriga, we're going to look for 3 star clusters in a row, M36, 37, and 38. And on this picture here, you can make those out here, here, and here. And those star clusters have between 200 to 400 stars each. And they are approximately, although they're at different distances, but on average about 4,000 light years away. So again, another really interesting open cluster target to put on your viewing list. M37 is kind of a close-up of one of these. Again, this cluster contains at least 12 red giants. And here again, by having that information in your hip pocket as you're going out and you're trying to identify, hey, am I looking at M37? You can look for the red giants and confirm that, yes, indeed, you are looking at M37. We're now going to go over to Gemini. And so if you remember, we want to go from the right foot up to the left shoulder. So the star Rigel up through Betelgeuse, and that'll get us close to Pollux and Castor, which puts us into Gemini. Gemini has several open clusters of interest, M35 being one, which is down here kind of near the feet of Pollux and Castor. And let me see if we get a picture of it. Yeah, here we go. So it's about 2,800 light years away. It's quite large. And let's see, I don't have in my notes here anything about red giants, but it does look like there are some, and I think I mentioned that earlier, M35. That's M37. So M35 looks like it does have some red stars again that will help you confirm that you are indeed looking at M35. And I kind of glossed over it, but understanding the shapes of these constellations is really important because you use those stars that are part of the constellation to get you close to an object. And in some cases, you actually have to kind of triangulate and move up and down off of the line that connects 2 stars. This one's probably pretty easy to use, though. If you can get down to the quote unquote feet or the leg part in Gemini, then you should be able to see this cluster because it's fairly large. And then here is a kind of a macroscopic or a bigger picture view of Gemini. And again, showing the various objects of interest here. There's one called the Eskimo Nebula, which is, let me just look at my notes here. Let's take a look. Here it is, 2392. This is actually a planetary nebula. So like the Crab Nebula was the remnant of a large star that ran out of fuel and died. Planetary nebula is actually the remnant of a smaller star like our own sun when it runs out of fuel and dies. And that's what you see here is this white dwarf that forms in the middle, still radiating a lot of energy and making the material that was blown off of the shell of the star, but still around the old star, making that glow. And then here you can see an image of that. So that's Hubble. Oops, excuse me. So that's Hubble, which is really, really nice. But this is kind of what you would expect to see from a small telescope. And you can make out the faint kind of fuzzy light that you see here. All right, so now we'll move on to the hunting dogs of Orion, which are Canis Major and Canis Minor. We'll focus on Canis Major, the big dog. And as you recall, we get down to Canis Major, or Sirius rather, by going this direction off of Orion's belt. And it gets us to this very bright star. You can't miss it. And in Canis Minor, or Major rather, we've got an open cluster that we'll be looking at. Actually, a couple of open clusters that we'll be looking at. Here's M41 and then NGC 2362. So M41, a little bit of history here, probably something that Aristotle would have recognized and was cataloged by Charles Messier. It's about 2,300 light years away. And again, beautiful orange star lies at the heart. So getting back to that theme, look for the different colored stars that might be in that cluster. And again, that can help you understand if, yes, that's M41 that I'm looking at. And this one's very large and very luminous. So this would be a really good marker or indicator. Here's 2362. Here we have about 500 stars in this particular cluster. And these are quite young, I think 4 to 5 million years old. And because the star, when stars form, they form kind of as a group, kind of like a litter of puppies, for lack of a better term. But we are in Canis Major, so an apropos analogy maybe. But you get a grouping of stars that are formed. They tend to have the same consistency, the same attributes. And in this particular case, because they're kind of like a sample size, you can study these to better understand, in this case, gas giants and their formation. So again, an interesting cluster. Okay, so those were the areas around Orion that we were focused on. Now we're gonna turn and face north. So if we have our sky map piece of paper, we want to turn it upside down so that north is on the bottom. And we're going to first turn our attention to Cassiopeia. And Cassiopeia is the queen. And this is kind of the mythical, legendary picture of what Cassiopeia is all about. Now, I'm a little bit simple in my thinking. I like to think of Cassiopeia as an M, as it's coming up over the top of its rotation around Polaris, or if it's coming down the bottom as a W. Either way, Cassiopeia is one of those very recognizable constellations. And so we don't have a signpost that would take us to Cassiopeia, but if we look north and we look up around Polaris, we can find this one. And so here's what Cassiopeia would look like tonight at about 9 o'clock, again, facing north. And here is the meridian, which is kind of the point at which things will rise up. And then once you pass that point, it will begin to rotate back down towards the horizon. And we are going to focus on the Heart Nebula, which is a mission nebula that is close by, trails, in this case, kind of the M in Cassiopeia. But this is, again, another emission nebula that we can go out and view in the night sky. This has some features that are similar to the Rosette Nebula, in that we have a group of really bright stars that are radiating a lot of energy and moving around the dust and the gas that are in and around the nebula, the cloud, and clearing out pockets, if you will, of space. So that's what we've got cooking here. This one's about 6,200 light years away, so it's kind of in the same neighborhood as as the Rosette Nebula, only on the other side of the sky. And again, a small group of stars in the core is probably what's ionizing this material that you see here, this gas and dust here. And here's that group of stars in here that's ionizing that, and probably also creating these stellar winds that are, again, creating these pockets that you see here. And the Heart Nebula is really a pretty object, very cool to go out and look at. We'll now go over to Perseus. Perseus is another constellation. For me, it's not as easy to find as Cassiopeia, but if you can find Cassiopeia, you can kind of go to the, if Cassiopeia is at this point in the night sky, you can kind of go to the upper right-hand direction and you'll find Perseus. And that's what we've got right here in this, this yellow box. Not an easy one to find, though. I'll be honest with you, to just go out there and try to find it without first finding Cassiopeia is a difficult task for me. There are some cool things in Perseus. There is a triple star system, but there are two stars that eclipse each other. There's Algol, and Algol's got let me see. I should rehearse this better. Rather than spend a lot of time fumbling my way here, what we have here is an eclipsing binary star system. And here is a nice animation that kind of shows you what's going on. So, these two stars are gravitationally bound to each other. One appears to be orbiting one around the other. And I'll go back to the previous slide. It has a orbital magnitude of about 2 days, 20 hours, and 49 seconds. So during that period, what you'll be able to see is the dimming of the star due to this eclipsing of the one star passing in front of the other, the brighter star. So very interesting. I've never seen an eclipsing star before. The period here, you'd have to kind of do some math in your head to make sure you were out there at the right time to see the eclipse, but very interesting indeed. Here's the last object on our list. It's the California Nebula. So again, we were up in Perseus, and we'll go out into this one leg of stars out here, and we'll be able to see the California Nebula. Another trick that I use to find the California Nebula, or at least get an idea of where it's at in the sky, is if I find Pleiades and I kind of draw a line or move my eyes over towards Perseus, you can find it. You can get the location down relatively quickly. I photographed the California Nebula a while back. I did it again, but a while back I did it, and I've got trees in my neighbor's yard, so I was only going to get so much time before the object went behind the trees. But I used Pleiades as kind of my frame of reference to see when I was about to run out of space. So just a kind of an aside there. And then here is a image of the California Nebula. This has a really interesting star here called X Persei, this really bright star here, which is probably responsible for the glow that you see with this gas and dust cloud that's shaped like the state of California. X Persei is actually a runaway star. And what I mean by that, it's a star that's moving in a direction that's not necessarily aligned with how everything else is moving around the center of our galaxy. If I can, let me find the proper way to state this. And I'm trying to, X Persei has a runaway star. A star is moving at a high velocity relative to its surroundings. So that is what we have here with X Persei. Now you may be asking yourself, well, what made it run away? Well, there could be several reasons why X Persei is running away. It could have been part of a double star where its companion star went supernova and flung it away. That's one possibility. It could have been near another star that went supernova in the neighborhood and got pushed away due to the tremendous force from the supernova. It may have even collided with, something as innocuous as an open star cluster or something of that nature. But those are the types of things that can send a star, make it go rogue and run away, as they say, and not necessarily be part of the normal motion of stars and planets and nebula here in the Milky Way. One last thing about X Persei, it's about 30 times the size of our own sun. It's a blue giant and a very easy star to see when you're out underneath the night sky. And Jupiter is still up, so don't forget about Jupiter. There are some, we went through opposition with Jupiter. Was it November, or I think it was in November? So it's still up in the sky. We can still see it, and it's still available for viewing. Here is a list that I made of all the objects that I've covered here in tonight's topic. And I've got some suggested methods by which to go out and view. A lot of great objects on this that can be seen with naked eye or binoculars, and even a small telescope. So, a lot of meat for the meal here, as they say, to go out and observe during the winter night. So that's really neat. There are also some upcoming celestial events you ought to be aware of. On the 7th, which is Sunday, Mercury will be at dichotomy. I didn't know Mercury could be at dichotomy. I never heard that term used before. So you learn something new every time. It's going to appear as a half phase before sunrise, and I think that's what the meaning of dichotomy is here. So that's something to look out for if you're an early riser. Also on the 27th, Mercury and Mars will pass within 12 minutes of each other. And if you recall, back in 2020, we had the great conjunction between Jupiter and Saturn, which I think was in the neighborhood of 6 minutes. So this would be pretty close. And so that's another thing to go out and check out. And again, I think these are right before sunrise. So you got to set the alarm clock early and get out there and look. And then finally, there's a meteor shower going on right now, the Quantreds. It's a major shower. I've seen some emails on the distribution list come through talking about, hey, I saw, some of the meteors from this meteor shower. It's got another week or so left. So if you've got some time and want to go out and maybe catch a meteor shower, this is a good one to go see. So with that, let's get out there and stargaze. Again, there's more to come in 2024. And in order to help you along with that, what I wanted to do is just kind of give you some information. I'm going to be putting together a winter novice lab. And again, I haven't really come up with dates yet, because I really want to find out who's interested and, when they can make it. But so what will we be doing? We'll be touring the night sky, and we'll be practicing going out and finding these objects out in the sky. So that sheet of paper that I had, that list, we can make a print out of that, bring it out to the dark site, and use that as our target list. And above all, have fun while we're out there doing that, learning the sky, learning. What I really want to do this year is put into practice the things that I'm talking about in these quarterly presentations. So that's the intent. We'll, in all likelihood, have it at the dark site. Members that are dark site qualified then will be those that would be eligible to go out. So if you're a member and you haven't been dark site qualified, you can go on to the HAS website and go take that training. It's not too difficult, and make sure you're qualified to come out. And then as far as when, again, what my plan is to tee up an email here in the next day or so, send that out to the wider audience of HAS and find out who's interested, and then also get some dates. What I would try to do is get out there when it's when the moon's not glaring at us and we have a fighting chance of seeing these objects. But we'll take what we can get because of the weather. Weather hasn't been too cooperative here lately, but again, I'll solicit. If you're interested, you can let me know and let me know what dates work for you, and we'll just kind of take it from there. This might end up being in February. That's fine too. We just want to make sure that we have the time to set it up and get out there and get out under the stars. One last thing before I wrap up and go to the questions. Be sure to tune in to tomorrow night's topic. General topic is called Recurrent Novae, and our speaker will be Walt Cooney, and that's going to be another great presentation as well. So with that, I will stop talking and I will go to the chat, and let me go to the top. And Mr. Dean Kopek, I hope I pronounced that right. Where is Orion in relation to Sirius? So let's go take a look. Let me just fold that up here. Bear with me a second. Let's go back. So remember, let me get to the right one. So here's a good picture. Again, we use it's kind of down lower off the kind of the left foot of Orion, and we can use the belt to get down to Sirius. So as Orion's kind of up high in the sky, you'll see Canis Major and Sirius kind of down to the lower left of him. And so that's how you find. Did I answer your question, Dean?
Yes.
Okay, real good. Okay, Lucas Simpson. I brought my 11-year-old son an Orion Star Blast 2 4.5 equatorial reflector telescope. Do you all meet in person where he can learn more about the functionality of the telescope and how to navigate the night sky? I think this meeting is a little above his head. So, and that was from Mr. Lucas Simpson. So, here's what I would say, Lucas. Certainly can bring the telescope out. I'll be totally honest with you. I'm not a telescope expert per se. I will certainly try to help anybody set up and use their telescope, but results may vary. What I'll be bringing out there is a pair of binoculars and a 10-inch Dobsonian telescope so that we can all use. So you don't need to worry about necessarily having your own telescope. Everybody will certainly be able to use this Dobbs that I'll bring out there. And then as far as the question, do we all meet in person? So the novice lab, I hope answered that question. And we will be focusing, on how to navigate the sky, naked eye, and then pointing our telescope at, following our use of the signposts, etc. I will definitely simplify that to the degree that I need to for anybody that's out there. I think it is a lot simpler once you get out there because you can actually see what's going on. And I have a much easier time explaining to anybody the signpost, how you use it, where you're at in the sky, that kind of thing. I'll bring out a laser pointer, but I've got to be real careful with that because if there are others out there that are doing photography, I've got to, or visual observing anybody else that's out there. I just need to be very respectful of their night vision. But we have in the past been able to use that, and that makes it very easy to point out in real time, what we're doing. So did I answer your question, Lucas? Are you there, Lucas? Okay. Marcia L. Bowen asked, what magnification are the photos? That's a tough question. First of all, the photos that we took that I showed here are not photos that I took, and I don't typically refer to magnification when we're talking about astrophotography. Really, what I'm referring to is field of view. If you're really interested in that, Marcia, I can get back to you on that, but I just don't have a short, sweet, and correct answer for you. Would that be okay, Marcia?
Well, that's Marcia and Peter.
Okay.
And the question was from the standpoint of what kind of a telescope. I mean, how much power do you need to get that clear a picture of the sky? Because I mean, right now I've just got binoculars.
Right.
And I think they're like something like 20 by 50 or something like that.
Okay.
And, so there's a lot in those photos I can't see.
Right.
And then I have another question, and this is more detailed.
Sure.
How do you use that star chart? I mean, I understand this idea of right ascension and declination, but what I don't get is how you use that from the position, I'm in here in Houston,
right,
to use a chart and look at the sky and be able to see on the chart what I should see from where I am. I don't get that.
Okay, well, let me see if I can clarify that. And back to your first question. So I do a bit of astrophotography myself, and in order to get, say, like the California Nebula, I've got a telescope that's essentially the size of a telephoto lens. It's a 249 millimeter focal length, and it's only 60 millimeter aperture. So you don't need a lot of telescope. What you do need is you need a camera, and you need to take multiple pictures of it and then develop them in order to get that much detail. So you'll notice in my table at the end, I've got this one designation called EAA, which is electronically assisted astronomy. And by using a camera and a small telescope, you can bring up images like we saw tonight. They may not be as detailed and as pretty as what you saw, but you can bring up images that are very close to what are in those pictures. Now, if people had an interest in doing that, I would do that at a place other than the dark site, and like my house or something like that, because there's a lot of light that you emit, and it's easier to demonstrate when you're not in a restricted area. But so anyway, I just wanted to throw that out. So So the maps that I showed you, the books and the maps, that one that folds out like a gas station map, those are nice references for tabletop purposes in your den or in your house. If you're going to be out in the field, the sky map is really the way to start, in my opinion, because what you're doing here is you're taking this piece of paper, you're going out at 8 o'clock at night, and you're facing south. You've got the map down south, and these objects that you see up here, that's what you'll be seeing. So you'll be able to look off to the southeast and see Orion. If you turn the map, and then down here you'll see Canis Major. You see the dog down here, Canis Minor. Here is Taurus right here. So this is a great way, a simple way to be able to go out and have some kind of reference material that will, show you about where these things are and about what they look like.
Yeah, well, I mean, I can I picked out a lot of what you've said tonight.
Mhm.
You know, like the stuff around Hyades and the Pleiades and the a little bit of Cassiopeia. I don't see that quite many of the stars of that yet. But I mean, where I've read things and heard people talk, they say these star charts are really useful, and I don't. I mean, I got the that well, it's a what do they call it? The large sky map or whatever.
Mhm.
Anyway, I have it, but I
Mhm.
just don't know how to use it or why it's a good thing to have.
Okay. You talking about that Deep Map 600? Is that what you're referring
No,
to,
no, no,
or like
no.
a big reference material?
It's on my.
Are you talking about the Pocket Sky Atlas?
Yeah,
Oh, okay.
yeah.
Well, so I'll just share with you again my philosophy on this, and then if some of the more experienced members want to chime in, for sure do so. To me, a big sky atlas that you have in your home is not necessarily something I would start out using outside. Okay. I would start with the sky map because it's one sheet of paper and it's very simple, and it kind of can help you find these objects and get yourself up to speed. As you get more experience and as you dig into the topic, as you dig into astronomy more deeply, then the references would be, I think, of more value to you because you've got that background information. So that's how I would approach it.
Okay, well, I sort of get the idea.
I mean, Bill or Steve, you guys have done this much longer than I have. Did you have any words of wisdom on the topic here?
Chris, this is Bill. The first thing that comes to my mind is would be a lot easier to explain outside under the stars than on a Zoom call. I think an awful lot of the things you're trying to explain would become more obvious if you could compare it to the sky that you're looking at.
Right. And again, that's the whole idea behind the Novice Lab is to make space for that so we can get out there and get some.
So I look forward to that.
Okay.
If you have the Pocket Sky Atlas in the front, it has like a table of contents of what constellations are on what maps. And if you say, "Oh, I'm looking up there. I see Cassiopeia," go look at that table of contents, see what map it's on, and then you can go further down and you get more detail and see more objects that are on the list. Does that sort of make sense?
Yeah, it does.
Okay. Dean, you've got another question here. You want to come off mute and ask it? It has to do with the Skywatcher HEQ.
Yeah, I've got a Skywatcher 5 or H5EQ. I can see Polaris. It's blocked by trees. Mm-hmm. So I set it up basically to 29.5 degrees, which is my latitude. So that should get me to the right latitude that Polaris would be at. If I then set it so that it's exactly 180 degrees away from the sun at noon, that should have me pointing north. Am I correct? If the sun is 180 degrees south, then so I should be within a couple of degrees of Polaris.
Yeah.
But when I tell it it's a go-to mode, so I say, let me do a 1-star alignment. I can see Sirius big and bright in the sky, so I say, go to Sirius. Mm-hmm. And it thinks Sirius is down here.
Right.
And I have to go up like this to find it.
Mm-hmm.
After that alignment, I may say, let's go to Jupiter. And then they say, Jupiter is over there. And I have to go about 10 degrees off. Does that sound like I just user error yet? Learning curve or defective?
So I have could you go on mute?
Can you go on mute? Yes.
I'm going crazy. I'm hearing myself. So I have the Skywatcher HEQ5 myself that I do use for astrophotography. The only reliable way that I've been able to Okay, Dean.
Okay, Dean.
Can you mute?
Can you mute?
There you go. All right. So the only reliable way that I've been able to star align is by, and I can see Polaris. I'll actually go ahead and set this thing up and aim it as close to Polaris as I can. And then I polar align it using a software called SharpCap. And then once I've got that polar alignment and the telescope knows that it's, the mount knows it's looking in at that position to, at Polaris, and then I slew to a star, say Rigel or Aldebaran, which I did the other night. It typically gets me close, and then from there I have to use the hand controller to get it right on Aldebaran, which I did Friday night, and then I do like a 1-star alignment, and then I slewed to the California Nebula, and that worked. It got the nebula in the frame of view. And then I have to make adjustments to get it more aligned up in the center of the picture. But unless you get that polar alignment, sometimes you're going to have that error. I'll be honest with you too. That the night I was out there Friday night, I did my polar alignment, had everything, going the way I thought it should be going, and I saw Deneb kind of off to the side, that it was kind of lower on the horizon than the other stars were, because Aldebaran hadn't come up above my eaves of my house yet. So I hit go to Deneb, and yeah, like you were saying, it was aiming down towards Australia. So, when that happened, I just kind of reset everything and then waited for a star like Aldebaran that I knew it was up in the sky and that the mount would recognize. So anyway, I don't know if that answered your question, but that polar aligning is pretty. I found that to be key in order to get it.
Yeah, I'll call it that. There's user error at this point. One other quick thing. I can't get into the website. It keeps asking me to change the password because I just got on, a couple days before Christmas. Okay. And so, here's a link to change your password. Well, it wants a password to change the password.
Hey,
so if you ask the web, go ahead.
I'll take care of that.
Very good. All right, thank you.
Okay. All right, Dean, I assume I took care of you there. Let's see. Dawn, do you find that an app like Sky Safari Pro might help the gentleman learn the sky a bit more? Absolutely. And we will go over using apps like Sky Safari and Sky Guide when we're out at the Novice Lab. The one thing that you've really got to be careful of out at the dark side is the amount of white light that you're emitting. And I've got some special sheeting that I can put over the face of my iPhone to keep it within the regulations, if you will, of the amount of light that we can emit. And I'll send out that information before we go out to the dark site so that y'all can, get that same material and use your phone. And it's a great way to do it. I would say as we start out though, what I would suggest is that we really try to do it old school, like with the sky map, with our naked eye. And you'll find, and again, when we get, like Bill was saying, when we get out there and get under the stars, I think it'll be a lot more, it'll be a lot clearer for you. I hope it will be anyway. At least you can ask questions while we're out there and I can help clarify things. So, but yeah, we can talk about using apps and all that stuff as well. So good point, Don. Appreciate that. There is a Scott Carnley who has his hand raised. Would you like to come off of mute and ask your question?
Yes. So one of the books, I think it's slide 16 that you have on the screen now. The book is The Stars by H.A. Ray. I noticed that, in the book, they changed how you view the constellations. And this was actually the first book I ever read. And so when you look at these sky maps that you have on there now, should I be, I guess it's maybe a personal preference, but like all the other references I've ever seen, they're all based on what you have on the screen now by sky maps. So yeah, I didn't know if should I try changing my train of thought and how I see the constellations through the stars, or what? If that makes sense.
Yeah. I mean, he does what he does. He doesn't necessarily change the constellations. In other words, if you take away all the lines between the stars, the star patterns that you see in the book are the star patterns of the constellations. What he does is he changes the connection of the lines,
Correct. Yeah.
between each star, and his intent there is to give you a picture that's more accurate of what the mythological being is. Like there's a constellation called the Whale constellation, if I'm not mistaken, and he shows how a typical reference might have the stars connected, and then he shows what he's done. And what you can see is his depiction, his star or his connection of dots or stars looks more like a whale.
Correct. Yeah, I actually see that right now. Yeah, I just like I said, this is the first one I ever read, and so I kind of learned all the constellations based on this. But when I don't have this book with me, and I'm using like the star maps, I seem to have a harder time.
Okay.
And I guess my brain has not flipped to the traditional sky maps.
Yeah, I mean, so the way I learned all this, when I was starting, I've only been doing this since 2020. So, I'm a novice in a true sense of the word, but I focused on the bright stars first in order to just get me in the neighborhood of a constellation, and then I use the sky map depictions that you see here as my starting point, just because it was simple and I could take it outside with me, and take with a flashlight and read the thing. I think once you get the hang of identifying these constellations, and in particular the bright stars that are in the constellations, the connection of the stars to one another becomes less important. Um, Cygnus as an example, the swan. That one is, I can tell what part's the tail, what part's the head. It's really almost second nature. And it's because in that particular case, I photographed probably 3 or 4 objects in that constellation. So, that kind of forced me to learn that particular one. Now, when I come up on a new constellation, then yeah, you need to maybe go back to the HA ray to get a better, grounding on what I should be looking for. And then once you get out in the sky, out under the stars, then you kind of take it from there. But it's a evolution. When I first started out, and when I first started out, it's like, what the heck am I looking at? That was just kind of my first impression. Although I will say Orion's belt, that thing hit me like a bolt of lightning. That one was so clear and apparent that you couldn't miss it. But what I found is it's a matter of practice and just getting out there. I mean, and this is a great time of year to start practicing because, again, Orion it has so many bright stars in it. It's so easy to pick up that you can really learn your way around quickly. And again, I don't mean to kind of punt or duck the question, but it's kind of practice makes perfect. And again, getting back to the novice lab, I think that will give us give everybody an opportunity to kind of go out and see it firsthand and ask questions. So
right, yeah. I guess my question didn't have a real answer to it. It was more like the HA ray. I see it and everything like that, but should I have been looking at like you said, follow the stars, the bright stars? Yeah. So it was a very open-ended question, but I thank you for answering.
I think anything that works for you, that's what you do.
Okay.
So
Perfect. Yeah.
try different things, Okay, let me see. I don't see anything else in the chat. Does it, before we wrap up here, we went a little bit long, but I hope the discussion was useful. Does anybody else have any questions before we close out the session tonight?
Hello, Chris. This is Roy.
Yeah.
Yeah. Are you recording this meeting? Because I want a copy of that target list you showed earlier.
You bet. I am recording it. And you know what I'll do, Roy, when I send out the notice to the HAS people for the Novice Lab, I'll make a PDF of that.
Okay, great.
Put it in the I'll put it in the meeting notice.
Okay, thank you.
You bet. Anything else? Going once.
Yeah, Chris.
Yes.
There was another comment from Kaween. Says, I am a new member. Can I bring one of my sons along?
Oh, yeah. Yes.
Most definitely.
Absolutely. I'm sorry. I missed that. Thank you, Steve, for pointing that out. Yes, you certainly can. The more the merrier. Obviously, there'll be, there are some rules out there that we have to follow. So we'll be relying on you to work with your son to make sure that, lights are appropriate for, what we do out there. Flashlights need to be red. They got to have some covering on a regular flashlight in order to give us that red light. So there are some things there, but certainly, yeah, absolutely. Bring the kids along.
Hey, Chris, one more question. Can you bring up that target slide? I want to take a screenshot of it real quick because there's a few things on there. I jotted down some notes, but I want a screenshot of it right now.
Roy,
if you don't mind.
I will do that for you, buddy.
All right, thank you.
Roy is, for those of you that don't know Roy, he is a budding astrophotographer, and he keeps me honest. He asks a lot of questions, and hopefully I've been able to answer some of them.
Yeah, you have, and I'm glad. I came into the meeting late tonight, but yeah, Chris you helped me more than you know. I've been, I just started astrophotography, probably back last year, and I would say August, maybe, right, because I just bought an equatorial mount and a new telescope, refractor, and a new camera, using Sharp Cap, and I'm learning a lot just by going out and just trial and error. I mean, I set a couple of nights ago, I imaged M42, Orion's nebula, and it was like 45, like 30, probably 38 degrees at night. I was outside for 8 hours that night.
Mm-hmm.
And of course I had my heater out there, propane heater, and I was dressed for it, but I set out in the backyard for 8 hours from 7 to about probably 2:30 in the morning.
Yep.
And it was great, man. It was clear. It was a cold night. It was just crisp. I mean, I live not far from you, New Caney, here down 59. And
right.
I mean, you can see the stars out here, but not like the dark side. But I got some decent images for the first time. I mean, I just, I'm enjoying it, and I'm glad, and I appreciate what you're doing here, Chris. I really do. Thank you.
Were you able to get the screenshot?
Yes, sir. I got it.
Okay, listen, we're at 8:30. Any more questions? Going once, going twice. All right, folks, thanks for joining tonight. Look for my email for the Novice Lab, and everybody have a pleasant evening. Thank you.
Thank you, Chris.
Great job, Chris.
Have to thank you.
Have to qualify for the dark side.
Well,
you do.
Yeah.
Correct.
Okay.
And that's just questions on the website.
There's a quiz that you have to take. Yeah.
Right.
And
okay.
Go onto the website on the observatory tab. Down at the bottom, you'll see a big blue button that says "Take the test." That's where you take the test. That's where you find it.
Okay. Thanks.
All right, everybody. I'm going to sign off here. So y'all have a nice evening.
Thank you.
Yeah.
All right.
See ya.
Take care.